Hello everyone, I'm Xiao Gang. Okay, in this lesson we'll talk about this paraphone. This paraphone thing is actually a kind of convenient writing method. You can see it has the advantage of allowing you to specify how many times to loop. Here, the first parameter is the loop count, and the second is our lambda. This lambda has no return value, but it can accept an int center as the loop count. Then there is this force single line, which forces a single thread, mostly used during testing. Essentially, it's the same as you writing a for loop with a root variable. It's the same thing. And then this part is about whether to push it to the render thread to execute. That's roughly what this function does. Let me just demonstrate it for everyone. Actually, it uses an enum. This function should be using this enum. You can see this is the default behavior. This forces a single thread, and this is a non-uniform behavior, meaning that the computation time between tasks might be different, or something like that. Then this should use this high variable compilation. It's this kind of highly variable computation at different times. Use this, then push this to the rendering thread. You need to OR this flag in, and this part runs in the background. That is, you run it in a background manner. Let me demonstrate it to everyone. Actually, it's not easy for us to write this timing statistic here. Actually, we often write it like this. For example, if you have a for loop in your code, we do a for loop. We loop 100 times. And then it does tasks here. So because this part is equivalent to the main thread doing it, then you actually have to spend 100 units of this time. For example, if I am here, I start 100 asynchronous tasks, or whatever method I use to do it. Then based on my processing speed, it will execute significantly faster than this, and it is equivalent to the main thread, only needing to wait for it to execute. Let's not start 100 here. Let's start 10. I can demonstrate it to everyone. Well, just, if we start 10, each one sleeps for linear 1 seconds. Right. Each of us sleeps for 0.1 seconds. We can do this. Theta time. We give it then this value should be a check value. Let's see if we can tick, get ticks. Okay. What is returned here is just an int 64. Let's compare this parameter. It should be my last tick. After execution, we take this. Let's get another one. Our current tick. Then we subtract the two numbers. Then we treat this as equivalent to. We actually have something like this, different value. We call it tick delta. It equals the difference minus it. Subtract this. Then we print out this number. Here we still use log temp. Then later, when we write I need, we will write it using this logging method. And here we write decatelta equals 100之1. Then we put this value in here. Okay. This way we can see a time. Right, this should be fine. Take a look here. There's an error in other places. It's because we missed writing one. Actually, the engine has many tools for calculating code runtime analysis. It uses this red method. We'll explain it later when we encounter it. Then here we have a portrait format. Let's also run it 10 times. And for the sleep time, we'll set it to 0.1. Okay, let me think. Let's make it a bit longer. Set it to 0.2. Then here we go ahead and get this time. This way we get a client tick. Then last tick. We take this time. We put it here. Actually, here we can have it capture an address. For example, we have an int32. We call it max number. Max number, we need it to equal 0. But there's a problem here. That is, if you capture this address here, you'll find that actually, right, doing it this way. If, for example, you write it like this, then you'll need to add a lock. You need to add a lock here. For example, if you want to write it like this, right, then you need to write a lock here, just like we did before. But we won't write it that way. Adding a lock like this would actually affect its performance. We'll just let it idle here. Then there is an index that will be passed in. After we finish executing here, we'll call powerful again. Okay, good. Then our port 4 should still be able to pass parameters. You should be able to see. We'll directly pass this flag. We'll teach everyone how to write this flag. It should be written like this. We run it in the background. Then we set a flag. We let it use this. We let it unbalanced method. Okay, actually, this way it can activate these two conditions because they are pieced together in this patchwork way. Using the piecing method, we just write it like this. Now let's execute this code. Obviously, this part will take about 2 seconds to execute, and this part might only take 0.2 seconds, but it needs a bit more because it might be requesting resources. So the total time should be around 0.2 seconds. And the reason we didn't apply for 100 here is that we don't want it to override the main layer. Okay, then let's add a program 5 here. Okay, now let's execute it. Watch our log. Look at our log. Actually, this part is still a bit much, still stuck. You can see the first one is 211,6000, and this one behind is also 2116. Let's check what the reason is. It's also very simple. It seems we didn't subtract it this time. But this is a minor issue in the code. So here we need to subtract it once more. Otherwise, its time would be the same. Let's separate them a bit. Let's execute it again now. Then we'll explain to everyone in a moment. If we want to add a lock, how should we add this lock? Okay, let's execute it now. Press 1. Thanks, U is stuck. Good. You'll notice that this time here is actually 012389. This part is 200,500. Let's take a look. How many digits are there here? 比如啊201. This is a 7-digit number. And this one? This is an 8-digit number, right? Look at this time. This difference, the performance is immediately apparent. Pay attention. The one above is an 8-digit number. This one is a 7-digit number. Yes. So this should actually be about 2 seconds. This one is around 0.2 seconds. That's roughly it. Then we can do it here. Let's say we now take this and add another tag to it. We add a tag. We add another one. And this time we add this one. We give it forces. But let's take a look at the effect. You can know ParallelFor. It actually takes the execution text inside, and then it will proceed downward. It will also perform the operation of suspending the current thread. Actually, we should check the number of threads here. Oh no, it doesn't matter. Let's just do it this way. We can open another thread here. This way it won't block the main thread. The main thread, we use this thread, but we are not writing code here. We can ignore it. We are only doing a demo test for it. Okay, let's execute it once now. It seems we should wait about 4 seconds to see the result. You will find that this time is the same, basically the same, right? You see, so at this point, our powerful part actually ends here. Then we still want to emphasize to everyone, do not say this sentence here. It is very taboo. Do not host Tesla graph. Use this kind of long-running task. Not only should you avoid using long-running tasks, but the workload is too heavy. You should not use this thing either. It will take over your main somehow give it to Mr. Main, fill it up completely for you, then you won't be able to use it. Then let's write another one for everyone. Write a mode with a lock. Because sometimes we take shortcuts, it's just a simple way to cut corners. But everyone can design a proper lock. But when there's no time, we often cut corners like this. We just paste this code directly. It's still the same code. How do we do it? If we're calculating the sum from 1 to 10 here, actually just do it like this. We use int32max. We don't need this number. Number equals 0. Okay, right here it adds equals this. Okay, this takes 0.2 seconds, no problem. Then we can print it out here. Actually, it doesn't matter if we don't print it now, but we print it here. Okay, that's fine. Then after we finish this part, we initialize it. Here, we set this to 0. Okay, initialize it. Then here, we pass an address in. While passing this address, we need to get a lock where there is a lock in our thread, right? So we get this lock. We can just write this lock here. As for this lock, we'll just call it the number lock. Number critical. Obviously, I don't know how long this time is. So let's adjust this time as well. Let's have I take the remainder. Let's have it take the remainder of 3 seconds. This way, the time will make the time longer. Obviously, the sleep time here. We'll also have it take the remainder of I. Take the remainder of 3. Okay? Take the remainder of the chase, and now what we need to do is pass both of these things in. Pass an address first. After we come in, we sleep first. Sleep. We avoid creating this lock issue. After sleeping, we directly add the lock to it. Remember how to write the lock. It should be like this, lock. We store it in. It should be written like this. Let's take a look. Let's check how the thread here is written. Written like this. Let's go back. Just write it like this. Printing like this here is problematic. But it's hard to change it now like this. Oh, there's a lock here. Then lock it here. After locking it, we need to add this number to inx. Okay, so we are done. This is the result of such a parallel computation. Now, let's compare the time. Of course, we definitely need to remove the single thread. Okay, then we can print out this result. Let's just copy this line. Put this log here for now, we'll ignore it. We can check which thread it is executing in through the info code we wrote earlier. But actually, we don't care about that at this point. Let's see if this result meets our expectations. Okay, let's go to our level blueprint. It should be this parallel for lock. Okay, let's start the confidence check now. Now the blocking layer is blocked again. We just need to look at the result. Because we recorded the time. Yeah, in that case, this time might take a bit longer to wait. You can see the result is the same, but you can see that the first one should be, how many bits is it? It is 8 bits. And our second one, it is also 8 bits. Actually, the first one should have taken 9 seconds. The second one should have taken 2 seconds. Yes, that should be the case. It should be like this, right? Anyway, this effect is for everyone. The demonstration ends here. Yes, so this is one of the powerful aspects of ParallelFor. It is also a convenient aspect, but you need to be careful when using it. Yes. So basically, we have covered the basic knowledge for now. There are still some things we haven't covered yet. We will supplement them in the subsequent practical sessions. for everyone. For example, some thread wake-ups or notify, things like that. Everyone take another look. Use it more often. Okay, we'll stop here for this session. Thank you, everyone.